So this is what I came up with for the regulated filament supply. I have a 220 to 24 volt transformer that puts out around 400 milliamps, 500 milliamps really, which is just about enough to supply the preamplifier valves, the PCC88s, with enough current. After the transformer, I have an artificial center tap, which I'll be using to elevate the filament supply to around, I think, a fifth of the B plus, or the high voltage. After the center tap, I just have a bridge rectifier, a couple of filter caps, and an LM317 based constant current source that is set via R1 to 300 milliamps, which is what the series string needs. It's 21 volts at 300 milliamps. Each one of the valves has a 7 volt filament inside at 300 milliamps. So I'll be putting them all in series, and I'll be heating them with DC, which I think this setup brings it down to around 50 millivolts ripple peak to peak, which is definitely fine. That shouldn't be a problem at all. It should be very, very clean DC. The next thing I'm going to do is just to lay out a very simple board, a printed circuit board for this supply. So it's all neat and tidy, and I can just stick it in a box and don't have to do much freehand point-to-point wiring. So this is the finished board after about 15 minutes of laying it out and routing it. I just have the transformer sitting here, then here's the center tab, the rectifier. This is a 1 amp type, there's also plenty. Here's the output, here's the constant current source with the resistor, and I'll have the 4 filter caps I have down here. The next thing I'm going to do is I'm going to print this out on a transfer paper, and then I'm going to etch it in sodium persulfate in my homemade etching tank. I made this printed circuit board using the direct toner transfer method. It turned out alright, although there were slight problems with adhesion of the toner to the PCB before etching. That's why the larger square pads where the transformer sits didn't turn out so good. The tracks on the back part of the PCB are very nice. Only one of the tracks leading from a large square pad to the rectifier is slightly bodged. I just bridged it over with some solder, but at 300 milliamps it shouldn't be too much of an issue. This is the assembled PCB. The only change from previous video is that I chose to use a different transformer. This one is slightly bigger than the one I showed before, which is just to avoid unnecessary heating of the transformer. I've already connected power and some test leads for multimeter to measure the output in milliamps, and an oscilloscope to check the ripple. So I'll just switch it on now, and it shows 303 milliamps, which is totally in spec, and it should worked just fine. The ripple as seen from the oscilloscope is around 5 millivolts peak to peak, but not even sure if this is just noise on the line or actually coming from the power supply. One improvement that could definitely be made here is that I placed the heatsink for the LM317 and the power resistor right next to those capacitors. They are 105 centigrade rated, but still it's not good practice to put something that heats up a lot right next to a capacitor.